Good day, our viewers. In this virtual class, we are going to look at our linear equation. I'll continue from where we stopped in our previous class. Our linear equation of the form ax plus bx plus b is equals to cx plus d. Number 2, ax plus b is equals to cx. Now, this equation is different from the one we used to in our previous class, like y is equals to ax plus b. Here you see that in this equation the unknown is just 1, but here the one we will be looking at today is an equation where we have two unknown on both sides and two constant as well. So here we'll look at how do we resolve this type of linear equation. Okay, because we said that equation is said to be linear if the highest power of the unknown is 1. Okay, let's look at this example. We have 8x minus 12 is equals to 4x plus 8. Imagine we have a linear equation of this nature. How do we resolve it? That will be essentially our discussion on this tutorial. Okay, now what we need to observe first is that we look at this the unknown on both sides. This is 8x and 4x. Okay, then we look at the constant term here on both sides. This is minus 12 and what? And 8. On the left hand side, minus 12. On the right hand side is 8. So all you need to do here is that we employ the rule or the procedure of using the additive inverse discussed in the previous video. Here we see 8x, we have 4x here. All we need to do, we look at the smaller one among them here. This is 4x is smaller, and between minus 12 and plus 8, minus 12 is smaller. So we're going to find the additive inverse of this minus 12 and 4x and add it to both sides. That's the first thing you do. Identify the smaller of the constant term and of the term containing the unknown. Okay, so here the two terms here are minus 12 and 4x. So that is what we look at here. So we'll find the additive inverse. So the additive inverse of minus 12 is plus 12. Additive inverse of plus 4 is minus 4. So the next step here, you say add plus 12 and minus 4x to both sides. To both what? Sides. Here we have 8x here before, and we're adding this one to it. We're adding minus 4x plus 12. We're having minus 12 here, we attach it to it. Then we'll come to this side, we have a 4x minus 4x plus 12, and there is 8 there before. You see the procedure now. Okay, we will see that this and this, they are off. Let's remove this and this, they are off. Okay, and here 8x minus 4x, that will give us 4x. 12 plus 8, that will give us 20. Okay, the process has been reduced. But the one we are used to, we can also say collect like terms by moving this one this way and take this one to the other side. It will still work. But this procedure is perfect. It reduces all the processes to just a fewer processes. Okay, the next step is that we look at the coefficient of the unknown here of x is 4, and we'll find the multiplicative inverse of 4, which is 1 over 4. The next thing you say, multiply both sides by 1 over 4. So here 1 over 4 times 4x is equals to 1 over 4 times 20. So this 4 will go with cancel 4, and here 4 here 1, 4 in 20, that will give 5. So s is equals to 5. But we also have a process of doing this. Like I said, you connect like terms, it will still work, but this process is unique. Okay, then let's look at another example here. Another example. For instance, if we have we have 6x minus 4 is equals to 2x. Okay, we're asked to solve this. How do we do this? This is typically of this nature. All you need to do is you look for here the 2x here on the right hand side containing the unknown and this constant term here. So that means I will need to collect like terms. And if we are going to do that, we'll look for the additive inverse of minus 4 and that of 2x and add it to both sides. So now we say add, this is minus 4, we say add 4 and minus 2s to both sides. To what? Both sides. So here we have a 6x minus 4 plus 4 minus 2x is equals to 2x minus 2x plus 4. So the first thing you have, look at this, look what number do you need to add to 4 to make it 0? That is plus 4. What x number do you need to add to 2x to make it 0? That is minus 2x. So having done that, here you see this is off, and here we have a 6x minus 2x, and here 2x minus 2x is off, and we'll be left with only 4 on the right hand side. So 6x minus 2x, that will give 4x is equal to 4. So here sometimes you say divide both sides by what? By 4. But in this case, I will multiply both sides by what? Multiply both sides by 1 over 4. So we have a 1 over 4 times 4x is equal to 1 over 4 times 4. So x becomes what? 1 in that situation. Okay, this is how to resolve a linear equation of this form. So given linear equation of this form, what you need to do is to see that you identify the constant term on both sides, look for the smaller one among them, find the additive inverse of it, look at the unknown terms on both sides, identify the smaller one, find the additive inverse, and what you need to do is say add the additive inverse of the constant term, the smaller of the constant term, and the smaller of the unknown terms to both sides, and this will reduce this question to this nature. And you know, here you can easily resolve either by multiplying both sides by the multiplicative inverse of the coefficient of the unknown, or you say divide both sides by the coefficient of the unknown. Okay, now let's take one more example on this. Let's look at another example on this. Imagine we have x, have 5 over 4 b plus 10 is equal to p over 4 plus 5. So we're asked to resolve this. What do we need to do here? Our procedures are not quite different. You look at the constant term here and the constant term here, and all you need to do is to move, and then move this to this and move this one to the other side. Okay, that's what will happen in this situation. So we look at this one here. We look at this. And we also look at this. Okay? So we find the additive inverse of plus 10 and p over 4. So the additive inverse of plus 10 is minus 10. And the additive inverse of p over 4 is minus p over 4. So we say add minus 10 and minus p over 4 to both sides. Okay? Even if you are collecting item, that's what you usually do. You move this one this way, but then you will observe sign. This is plus as it's coming here become minus, and this is plus as it's moving this way become this is plus as it's moving this way become minus. So here we have a 5 over 4p minus p over 4. This is plus 10 minus 10 is equal to p over 4 minus p over 4 minus 5 minus 10. Okay, we will see that this whole thing is off, this one is off, and here we'll be left with 5p over 4 minus p over 4. Because the denominator are the same, you will hold it as 1, subtract the numerator 5p minus p. That will give us 4p. On this side, we're having a minus 5 minus 10. That will give minus 15. So here, 4 will cancel 4, so that p is equal to minus what? Minus 15 as our answer. So, this is all we take for this class. In our next partial class, we're going to take more questions and we step up on how to find linear equations involving brackets and fractions. Have a nice time. See you in my next partial class.